Welcome to the second video in my series on the Hound, my 3-pound BattleBot. This video was supposed to cover everything else that my little teardown video didn't cover, everything from the manufacturing of the weapon system to the math behind the anti-gyro. Unfortunately, I wasn't able to fit this all into this video, so this first one is going to be just about the construction, material choice, and how the anti-gyro belt system works. I'm going to try and make some videos in the future on the math behind the anti-gyro system, and then also some of the manufacturing methods I use to make this robot in the future. So that's what's coming today, and that's what's in the works in the future. Sorry I had to kind of come back to after the end of this and rewrite the intro, but enjoy the video. He is a little 3-pound robot, and I say little because it is very small for a 3-pound robot. When I was at the most recent competition, Spinner Spring, it got mistaken for a 1-pound, and everyone in the 1-pound class was very glad they didn't have to fight it when they learned it was a 3-pound robot. Now, my reasoning for making it so small is I see a lot of 3-pound robots that just get lightened and lightened and lightened until they're like just wireframe and barely held together and just pocketed everywhere. And I really didn't want that. I wanted a solid little robot. Looking at robots like the D2 kit, which I have been beaten by plenty of times, you can see its construction is just so solid that the drivers of the robots really never have to worry about taking a hit. And I really wanted that kind of confidence behind my robot. I wanted to be able to go into a ring and be like, yeah, my robot's going to be running after this, no problem, even if it gets hit by like stupid vertical spinners that are super heavy or horizontals that are stupid heavy. I want to still be able to drive my robot afterwards. And so to do that, I actually made it so that I can make my entire robot, all of these metal plates in here, out of solid steel. Now, right now these two are aluminum, which gives me the weight to add a titanium wedge in the future, which I am very interested in doing, considering how well my plastic wedges held up. Now, the other thing that I wanted is I want it to be very drivable. Now, that's another thing with the D2 kit that I saw, is people knew how to drive that, and when you can drive a robot and you have that confidence in your robot, then it's just crazy what you can do. Like, even without an active weapon, they can still get the control, push everyone around, you know, really, really do quite a bit without an active weapon. So I really wanted that. And to do that, I actually designed and built, as far as I know, the very first BattleBot with an anti-gyro system. Now, how I did that is I designed up the weapon that I wanted, and I found the moment of inertia. And then I found the ratio. Well, I made a ratio and kind of found a counterweight, you know, chicken and egg sort of thing. I don't know what really came first. But I messed with the belt ratio between the pulley here and the pulley on my weapon hub. And that way I could get them, right now they're about a 3.5 to 1 ratio, so this guy spins 3.5 times as fast as my weapon blades, so it can be 3.5 times less inertia. Now they actually weigh similar amounts, just because I had to make this one a lot smaller. The moment of inertia was smaller because it was smaller, so I had to compensate by making it heavier. So that's a bit unfortunate. I would like to see a higher ratio in the future so I can get away with a much lighter counterweight, put a lot more weight into my weapon and into my armor, wedge, etc. Putting weight into this counterweight really was a design choice that I had to make. And I'm actually quite happy with it, because if you watch some of the videos from the competition, you can see this robot turning quite a bit. And as far as I could tell, there was almost no gyro. There is a little bit of gyro you can feel, but it's nothing compared to when I ran the anti-gyro motor without a weapon. that was pretty crazy. I'll have to put up a video of that if I can find one. So yeah, that was fun, and I'm glad that it worked out, because I really still don't quite understand all the math behind it. I can pull up some of that, get into that a little bit later, but I don't quite fully understand it. I just know it works, so I'm using it. Now, my pieces in between my metal plates, right now they are carbon fiber nylon printed on a Markforged because I have access to one, and I'm very grateful for having access to one, but they were originally intended to be PLA. They probably could be PLA, but like, come on, it's Markforged nylon. You can't get away with, or can't do anything else once you've gotten to that. Now, I wanted to get into the electronics a little bit, because they're another interesting part of this robot. Now, most people have one large central battery into their robot, and because I had a lot of space taken up by this crazy weapon system, and my drive motors are more or less the entire back of this robot, I didn't have much room for batteries. Now, I couldn't fit the capacity I wanted on one side, so what I actually did is I have two 3-cell batteries, which I actually had to build myself out of 1-cell batteries because I couldn't find any with the right size and ratings. So they're 3 1-cell batteries, and then they are actually wired in parallel with each other. And they're balanced across these leads right here. These 3 wires balance them for the negative, cell 1, cell 2, and then cell 3 and enable are up here. So this is the positive line. The positive of both batteries are connected, and then this is the enable line. This is connected to my power switch, and it just kind of sends the power back over to here to run my one drive motor. I probably could have used higher gauge wire for this, but really this battery on the left can handle the weapon on its own. So really it takes the burst of the current, and then this guy just trickle charges it as the match goes on. So, not the best, but it worked out for me. I had pretty much no problems with it. And because my batteries are soldered in, I can't replace them. That's going to be something I'm looking into the next version of Hound. I'd like to have replaceable batteries, even if it's a little difficult to replace them. We'll see how that goes. I'm not sure I can get that in this small form factor. I do have a balanced charging port up here. It's just a JST connector with 4 pins to charge the 3 cells. I have a little cheater cable that I use to plug it into a regular 4-button charger. I can show that in a later video. My drive here. I wanted 4-wheel drive because that's what most of the high-end drivers robots have. So I just belted the wheels together. I did not have room for motors up at the front. That's what I would have liked to do, but again, this robot is tiny, so I'm running out of room to put things, so I just had to belt up to the front. And that works pretty well. I did have a few instances where the motor shaft was sheared off by John, I believe, was the one who sheared off my motor shaft. So that'll take out the robot. But anything less than that, even if this wheel gets completely removed, the pulley is actually made of a lot thicker material than this hub here. So the hub should be able to be ripped off completely, and the pulley should still remain intact. So they would have to rip off the hub and then come back with a second hit and rip off the pulley to actually disable an entire drive side. Now, driving upside down, I do have settings in my transmitter that will reverse the weapon, so it will always spin upwards, and then it will also reverse the turning in my drivetrain, so that way I can have full regular control upside down. I actually never really used that, because I liked having my weapon spin this direction, so that way if I hit a wall, it would catch on the wall and kick the robot back up, and it would land on its wheels. That usually worked. And yeah, I really never had to use that reverse thing. I figured I'd just leave it in my transmitter settings just so that if something gets like jammed in here, I can flip that switch, reverse the weapon, hopefully kick out whatever foreign material was in there, and get back to the fight. So yes, this is the Hound. I'll be going into some CAD in a moment and showing how this belt path works and how it reverses the rotation of the motor. Oh, well, I guess that's my cue here. So here is the Hound CAD, and it's actually easiest to see the belt path here because even in real life, with the Hound split in half and only the motor and weapon in there, you still can't see the belt path because it's hidden by the weapon and the counterweight there. So the best way to see it is right here in CAD. So you can see a really unorthodox belt path here, and I do this that way I can get a gearing down effect from the motor to the weapon, and also so that way I can get it to go the other direction. And initially I had this with a set of gears, and then a belt from the second gear up to the weapon. I didn't really like that because it's a lot of added components, a lot more moving parts that could go wrong, and I never really liked the idea of having gear meshes in any BattleBot, because you tweak the frame a little bit, it could totally just throw off the gear mesh and robot would stop working. Belts are nice and flexible, they're a little bit stretchy, so that gives you a little bit of freedom there. The other thing you'll notice is I'm actually using a single-sided belt, but I'm using both sides of it for torque transfer. And I'm doing that for two reasons. One reason is because this way, if the weapon, takes a big hit, it's not going to transmit that shock back to the motor here, and that keeps the motor safe so this little tiny 1/8" axle doesn't bend. The other reason is I couldn't find any two-sided belts for less than $80, so I kind of just stuck with this. It worked out really well for me. I actually really like the clutch effect that I have up here that prevents any dangerous weapon impacts from going into the motor. Now, because this also gears up, as I said before, I can have a counterweight with a third the inertia of the weapon and still get that complete gyro cancellation effect. So yeah, that is the Hound system. If you ever want to make one yourself, it's pretty easy actually. Like there's no special sauce in here. This is everything. This is all you need to do. So thanks for watching. I hope I've inspired you in some way to make your own robot. And here's 45 seconds of me doing robot CAD, so that way the end credits don't cover up this video.